Good morning, good morning. If you just get here, attendance is on the right corner. I can also send it in the chat, but make sure that you stay, okay? We're not leaving today. Miss Mac isn't here today. I'm taking over classroom teaching, but it doesn't mean that you guys get to leave early today. How was your day today, Gracia? Let's take a few more minutes to wait for everybody to get here. It was good? Nice. Did you have a day full of classes? Mine was pretty good. I think I'm feeling a little bit under the weather, so you might hear some raspiness in my voice. So hopefully it doesn't affect too much of my teaching. But other than that, it's all good. Hello, everybody. So Miss Mac isn't gonna be here today and Thursday, so it's just gonna be me teaching. But make sure you don't leave the chat. We still have content to cover today, and I am sending the attendance. So go ahead and check in. And we're gonna take a few more minutes to wait for everybody to get here, or just wait for people to get here in general. Does the attendance link work for everyone? Is it working? Hello. For those joining, we are taking attendance. Okay, so Miss Mac isn't here, but she still wants me to share National Day with you guys today. So the National Day today is Lima Bean Respect Day. So it's probably not like the most common favorite food amongst young people. So the question for today is, what's one food you used to hate but you actually like now? So feel free to put in the chat. For me, I used to really dislike eggplant, onion. Have you ever tried cutting onion, Chelsea? I still I have to wear my glasses while cutting onions. You never tried it? You never tried cutting onions? Like chopping onions? Yeah. Yep. Yeah, no. I tried a lot. There's one yeah. Anyways. All right, let's take a few more minutes to take attendance and we're gonna move on. Feel free to comment what's the one food you used to hate but actually like now. Like I said, mine was eggplant. I couldn't bear the texture of it, but I don't know why. After I got older, went off for college, began liking it. All right. Okay. Cool. Oh. All right, so for today's agenda, we're gonna go through some announcements and then move on to the notes. Okay. All right. So we're done with week 1 with the first 2 polynomials classes or lessons. Today we're gonna move on to assignment 36. Miss Mack is out today, but she will be back next week. Okay, but make sure you still stay in the class because we have content to cover today and on Thursday also. Okay, so for office hours, new updates. So Tuesday, Thursday, still the same time, 10:30 to 12 p.m. But starting next Monday, I'll be calling people into Monday from 10:30 a.m. to 12 p.m. because for this quarter, I won't be staying with you guys till the very end. So I know last quarter, I had a lot of people requesting for office hours towards the end to help with assignments because I won't be here at the end. I'm trying to help you guys get through the assignments. So if you see my invitation on Mondays and you have a missing assignments and you don't have class, make sure you hop in. Okay. All right. So we're going to move on to the next portion. It's called My Favorite No. It's based on some of the questions that we got from the assignment that we had. Can I have someone in the chat to either come off mute or just type in the chat or private message me what you think this blue dot is. Is it single root, double root, and triple root? Yes, it's a double root, Hey Sue. Do we know why? Can you explain or just come off mute and tell people why it's a double root? Yeah, thank you. Can you tell people why it's a double root? Yeah. You forgot? Okay, no worries. So do you see like a valley, right? It's a valley or a hill, right? There's a parabola, a small parabola, right? So you see that there is that shape. So whenever you have a shape where it goes up and down or down and up on the two sides of the dot, that's when you know it's a double root. Single root would be just like a straight line going through, right? And triple root, there's like a flat part and then another curve. And that's how we know it's a double root. Cool. All right, this is the second question that we have. So this is a very smart response and a very good attempt. So here we have the equation x plus 1 times x minus 3. So the equation itself is actually correct. Can someone tell me what this m is supposed to represent? Again, feel free to type in the chat or come off mute. This is the lesson that we did yesterday, not yesterday, last Thursday, yeah. Yeah, thank you, you're right. So m, exactly, it's, okay, that's a good attempt. So it's where it crosses, kind of. So m actually represents the multiplicity that we talked about. Remember when you have a double root, your m will be 2, right? It'll be 2 multiplicity. And if it's triple root, it'll be 3. So right here we have a -3, and I think the -3 came from the x minus 3, and the 1 came from x plus 1, right? So that's not what the m is supposed to represent. M is supposed to represent the multiplicity, which describes the root, right? So here, because we have a double root at -1, how should the equation look like? Remember, double root means it's 2, right? So what happens at 2? How do I show it in the equation? Do I need to add anything to its current equation, x plus 1 times x minus 3? Feel free to comment or private message me. Or come off mute. That'll be even better. Yeah, so if you have a double root here, you'll actually show it in the exponent, right? So if you have a double root, the equation x plus 1 will become x plus 1 squared. If you have a triple root, it will be a cube, right? Hopefully that makes sense. But those are some really good review questions that we got from the assignment. Okay, if you have more questions, just let me know and we can go over them in office hours. All right. Okay, another thing is here in the example, we have x plus 0 as an option. So usually when we want to show 0 as one of the solutions, we just write x. We don't need to have the x plus 0. That's just like a common thing that we have across the homework assignments. All right, here we have shout outs to some amazing notes from Melanie, Zephyr, and Jessica. There are a lot of great notes for the past assignment, but we just want to highlight those notes in general because you see how they use a lot of different colors and highlightings. So that was really, really good. Shout out to everyone. All right. Okay, so with that, that's all we have for the announcements. Let me start this poll. and to see whether we are ready for the note-taking section. Oh, not that one. Give me a second. Let me get the poll ready. All right. In the meantime, I'm going to switch to my iPad. Make sure that you're on assignment 36 or notes 36. Give me a second real quick to share. All right. Hope you guys have your pencil, pen, whatever you use for note taking. And have assignment 36 out. Awesome. Give me 1 second. I think we have a few more people wanting an extra minute, and we're going to take that minute. As always, if you want to come off mute and participate that way, feel free to do so, or you can use the raise hand feature and I can call on you. All right. Okay, I think that minute has passed. So for today, we're gonna be looking at Notes 36, sketching polynomials, right? So there are a lot of words in this note. So for now, what I want is you don't have to write everything on the steps. All you have to do is to have this box copied and especially have this equation and this graph drawn out. Okay? All right. So here we have an example function, y equals x plus 3 times x plus 4 times x minus 2. Recall how we solved for the zeros in the past 2 sessions. Can someone tell me what my solutions are? So we have x plus 3 times x plus 4 times x minus 2. What are my solutions? The title is Sketching Polynomials. And for all the people who just came in, this is your attendance, but make sure you stay till the end of the session because we have new content to cover. Awesome. All right, so I'm going to ask the question again. So we have y equals x plus 3 times x plus 4 times x minus 2, right? What are my solutions? My solutions are, how do I tell where my function touches the x-axis? Yeah, that's awesome. So you see how we have x plus 3? Our zeros are the flipped sign of whatever we have here. So if it's a positive 3, there will be a negative 3 here. So what would the solution for this part, x plus 4, be? Yeah, you want to flip the sign, right? So you have a positive here, so you'll have a negative 4 as a solution. And the last part, because you have a negative 2, you're going to flip that sign and you're going to get positive 2, or we're just going to write 2. So that's how you find the zeros, which corresponds to step number 1. Find the solutions and their multiplicity. Multiplicity meaning, do I have any exponents, right? So because we don't see any additional exponents, yeah, we don't have multiplicity. Thank you, Jesus. Right. The second question is, because there are x solutions, this is x to what exponent, right? So essentially, because we only have 3 x's and there's no exponents, we have 3 solutions. Does that make sense? I think this is a new idea. So because we have 1, 2, 3, three x's with no exponents, it means that we have three solutions. So this number goes to the exponent part of our x. So this actually is x cubed. And remember how x cubed looked like? You know how last Tuesday we were talking about how graphs look like? So x to the cube will look something like this. X to the fourth. Okay, so x cubed looks something like this, right? Yeah, no worries. Does this recall? Does this bring up any memory? Remember, this is a positive x cube function, and this is like a negative x cube function. Yeah, so this corresponds to part 2. I don't think you guys have part 2 on your notes if you just downloaded it today. It's called determine the degree of the function, right? Because I know there are 3 solutions, it's x to the cube. X cube, I already know, looks something like this, right? Cool. The next part. So in this box, my answer actually, we only have 2 options in this box. You can either be positive, oh my goodness, I cannot spell, positive or negative. Okay, so because it is either a positive or negative, it ends up going either up or down, right? So if it's positive, the end of our function on the right side is actually going to go up. So if it's positive, it's going to go up. If it's negative, it will go down. And we'll see an example with a negative very soon. So how do I know if it's positive or negative, right? So how do you know is by looking in front of your function. So if there's nothing in front, we know it's positive. If there is a negative sign in front, we know it's a negative, right? So that's how you tell whether it's a negative or a positive. And if it's an overall positive function like this one, we know that the end will go up. It will go upward. But if it's negative, it will go downward. Okay. All right. So that's the draw the ending arrows based on the leading sign. Okay. That's corresponding to part 4. All right, so now we're moving on to the actual sketching part, right? So remember sketching, we're not doing an accurate picture. We're just trying to see how it actually looks like, right? It's an estimation. So the first part is to plot the solutions, right? What we have here is to plot the solutions. So we have 1 and -3. So 1, 2, 3, 1 point at -3, another point at -4, and our last point at 2. Right? So now we have those points plotted. My next thing is to see, okay, so I know that it's a positive function. My ending of the function should be going upward, right? So it ends going upward right here. Your ends are always on the most far right, right? Most far right point will be your end. Okay, so I know that x -2, this part, do I have a root? Is this a single root, double root, or triple root? Can I have someone help me out with this? Is this a single root, double root, or triple root? Feel free to private message me or come off mute. And remember how we define roots? You look at the exponents, right? So if there is no exponent, yeah, thank you, Brandon. So it is a single root. So what happens to the single root? Am I going through the point? Is it look like this? Or am I doing like a little curve? This is like a double root, right? How does this point look like? How should I draw this line? Should I go through this point I have? Or should I curve up or curve down? Yeah, it's a single point. So we're gonna go through the point, right? If we curve upward this way, it's gonna be a double root. So we're not doing that. Okay, let's look at our next solution, which is at -4. Is this a single root or double root? Yeah, it's also a single root, right? Because we don't have an exponent. So instead of like curving upward or downward, we're just going to have this point, this line go through the point. So we're just going to have a line right here, go through the point, go up. All right. And my last point, oh, give me a second. Someone just came back. And my last point, is it going to be a single root or a double root? Yeah, it's also going to be a single root, right? Give me a second. Let me check this real quick. Mm, sorry, my iPad was acting up, so I'm gonna reshare the screen again. Cool. Okay, I think you guys should be able to see. Nice. So yeah, this at -4, right here, it's also a single root. So we're gonna go directly through the point, right? So it looks something like this. All right, I'm gonna launch a poll and please tell me whether you're confused at any step. So let's say find the solution. This is gonna be A. If you're confused at this part, you're gonna put A. Telling the degree, this is gonna be B. Defining whether it's positive or negative, it's C. And then this last part, sketching, would be D. And then part E will be you understand. Okay, let me launch this poll. I think it's this one. Cool. So again, A is if you're confused about how we got the zeros, how we got -3, -4, and 2. B is how we found the solutions. C is defining whether it goes up or down, which is defining whether it's positive or negative. Or D, the sketching part, right? And then E is if you actually get it. Right now we have 2 responses, 3 responses. Thank you. We're waiting for a few more before we move on to the next example to practice more. All right, I'm going to give 1 more minute for the vote. Awesome. Cool. All right, so we're going to move on to the second example, right? This second example right here is y equals -2x times x plus 3 times x minus 1 squared, right? So here, the first step is to find our zeros, right? Which is finding the solutions. Can someone in the chat tell me what my solutions would be in this case? This part, this part, this part. What are the solutions that I have? Thank you, Chelsea. So you're right. We have -3 and we have 1 here. The 2x part is tricky, right? So remember, to find the solution, what I want to do is to provide a scenario where the bracket part equals to 0, because anything multiplied by 0 equals 0, right? So here, when negative 3 plus 3, it's 0. 1 minus 1 is 0. How do I get 2x to become 0? What do I have to multiply 2 with to become 0? 2 times 0. Yes, awesome, Chelsea. So this is how we know that when x equals 0, my function will also be 0. So my solutions are actually 0, negative 3, and 1. Okay, we have our solutions at 0, negative 3, and 1. So we're going to plot them onto the graph, right? So we have one point at 0, we have another point at negative 3, and we have one more point at 1. Okay, that's how we get that. All right, my next step is to define whether there is multiplicity or not, right? We want to see if there is multiplicity. So to tell whether there is multiplicity or any exponents, we look at the exponent sign, right? So I'm going to circle the exponent. So this is one exponent, and one exponent. And remember, when there is nothing there, it means that it's 1, right? So I have 1 here, and 2 here. So can someone remind me what does 2 represent? What does the x1 and 2 mean? What does multiplicity supposed to tell me? Yeah, awesome. All right, I'm gonna tell Miss Mac and make sure that you get your merit, Chelsea. Okay, right. Because there is a square with x minus 1, I know that it has 2 for multiplicity. So what does it tell me about my shape? Is it a single root, double root, or a triple root if it's a square? Yeah, that's awesome. Yes, it is a double root. So I can write this as m2. No, m2, right? So let me revise this graph, right? So if I have a m2 on the graph, I'm actually going to show it using an x, right? So that's going to help me when I sketch out the graph in the end. Okay, so we have a point at 0, another point negative 3, and then one point at 1. That's supposed to be a double root. Remember, double root, it's supposed to be either a valley, a hill. No, this is a valley and this is a hill. Okay, so essentially it's like a parabola, right? All right, the next point is to determine whether this function is overall positive or negative. Can someone tell me whether this is a positive or negative function? Good try. Can you tell me how you got to positive? Okay, you guessed. All right. So this is actually a negative function because remember to check for a sign, we're going to look at the front of our function, right? So here we have an example where you see here is a negative in front. So we have a negative function, right? So negative, does a negative go upward in the end or does it go downward in the end? Yeah, that's awesome. It goes downward, right? So it goes down. Can you guys see the green or is it too like light? I hope you guys can see it. Yeah, awesome. So it means that towards the end of my graph, remember the end is the point that's to the most right of the graph, which is right here, right? Right here. So it means that it ends going down. So I can start sketching. And remember at x minus 1, we have a multiplicity of 2. It means that we have to draw either a valley or a hill, right? So it has to cave. So I will cave at this point, right? I had to have the cave. So at x equals 0 at this point, do I have a single root or a double root? Yeah, that's awesome. I have a single root, right? So I have a single root, meaning my point gets directly through. So we have like a point, a line going through the point. I'm just gonna connect these two lines. So this is the line we have. All right, last step. At x plus 3, do I have a single root or double root? Oh, Chelsea, okay. Do you have a question at x equals 0? Okay, that's an awesome question. So I know that when x equals 0, which is right here, right? We have a single root because you see there's no number written as the exponent. So to get a double root, your x, this part will have to be, yeah, if it's a double, it has to be squared, right? Yes, it's at the exponent. That's an excellent question. So because there's no number written, it's 1. So it's a single root. So single root, it means that you just draw a line through it. Okay, last one. At x equals -3, do I have a single root or a double root? Single, exactly. So it means that the point, there's a line goes through the point, right? So I'm gonna connect these two lines. Boom. And this is just gonna continue going down. All right, so this actually looks like, okay, let's count how many solutions we have. So we have 2, right? Multiplicity, so 1, 2, 3, and 4. Is it clear how we get to 4? 4 solutions? Because we have a 2, exponent 2, and then no number written here, meaning it's just 1 each. So we add them together, we have 2 plus 1 plus 1. So we actually get 4, right? We get 4. And remember, if we have 4, it means that we have 4 solutions. We have x to the 4th, which is 4 solutions. And remember last Tuesday when we were talking about defining the polynomials, if it's an x to the 4th power, it should look like either an m or a w, right? Oh, that's not w. Remember that decimal activity that we did? So because it's a negative, our w will flip and we'll have an m. And that's how we know, hey, this function actually looks accurate. All right, I'm gonna launch the poll again. And please tell me this time which part, boom, let me see how I can relaunch this. Okay, I just relaunched it. So let's see how I label it. All right, so don't answer the poll yet. The first at A is if you don't understand how we get to the zeros, it's A. And defining whether it's negative, positive, and down or up, it's B. And getting the number of solutions, that's C. Let's see, and D is multiplicity. And then E is the graph. And F is you get it. All right, I'm going to say it one more time. You're going to choose A if you don't understand how we get to the zeros, how we got to 0, -3, or 1. You're going to choose B if you don't know how we got negative or positive. And you're going to choose C if you don't know how we get the number of solutions. Okay, thank you. You're going to choose D if you don't know how we got multiplicity. And you're going to choose E if you don't know the graph. And lastly, you're going to choose F if you understand completely, which is how and where we want to get everyone. Thank you, Chelsea. All right, take another 30 seconds to fill this out, and then we're going to move on to our last question. Okay. And please let me know if this note that I just did, it was too messy. I know there's a lot of colors, so let me know and I'll try to make it more neat. All right, awesome. Cool. Awesome. Okay, let's look at our last question from our notes. Here we have a function y equals x plus 5 times x plus 2 squared. Can someone tell me where my solutions are? So what are the solutions here? Or maybe you're more familiar with the term. Where are my zeros? Awesome. Thank you. Thank you, Chelsea. Yeah, exactly. So our points are at -5 and -2. That's awesome. And we get that because -5 plus 5 is 0. 0 times anything is 0, right? Same with -2. So my next step is to see, okay, do I have any multiplicity thing? Do I have multiplicity at all? And remember multiplicity, you want to look at exponent. Yeah, because x plus 2 is a square, we have a multiplicity of 2. And this just means that it's double root, right? Double root means that it's either going to be a valley or a hill, right? Okay, so we've determined that. My next step is, oh, before I end that, so it tells me that I have 3 solutions, right? And to get the solution, all I have to do is to add them together, the exponents together. So if it's nothing, then it's a 1, right? A hidden 1. So I have 1 plus 2, which is 3. So I have 3 solutions, meaning my graph should look like a cubic graph, right? Cubic graph, remember, either looks like this or like this if it's negative. So this is a negative and this is a positive, right? So because we have 1 as an exponent and we have 2 as exponent, we know that we have 3 solutions. So it should look like either this or this. All right. My next step is to determine whether this function is overall positive or overall negative. Can someone tell me whether this function is positive or negative? Yeah, awesome. It's positive, right? So we know that this is positive. Yeah, exactly, because there is nothing in front. You are acing this section, Chelsea. So because there is nothing in front of our function, we know this is a positive, right? Positive meaning that at the end of our graph, it's gonna go up, right? And remember, at the end meaning at the very, very right, the point that's most far to the right. Okay, so now that we have -5 and -2, let's plot it into the graph, right? And we have 1, 2, 3, 4, 5, 1 point at -5, another point at -2. Oh, remember, because I know there's a multiplicity of 2, I'm going to draw an X to tell me that it's not just a single point going through. It's actually either a valley or a hill, right? So here, let's try, oh, and before we do that, before we sketch out the entire thing, let's look at the positive part. So at the most right of the point, between a -5 and -2, it will be at -2, right? Because we only have 2 points. So the one on the right, this is on the right, and this is on the left. -2 is closer to right, so that's our most right. So I know that it's positive, so it's supposed to scale up at the end. It's supposed to go up. Oh, it's supposed to go up. All right, and remember that we have a double root at -2, right? How should I draw this point? Do I go through the point, or is this either a valley or the hill? The hill meaning you're at the top of the hill, valley meaning you're at the most bottom part. How should I continue this line? Yeah, we want to go up, right? We want to go up because it's supposed to look like a parabola, right? That's awesome. So we're going up. All right, let me draw it a little bit smaller. So we're moving up. So maybe make sure that we curve up. All right, before we connect these 2 points together, let's look at -5. So when x plus 5, when we are at x plus 5, which is the solution -5, do we have the point going through, or is it also a parabola? Through, exactly, because it's a single root. That is awesome. So we have a point just going through, right? Because it's a single root. That is great. So now all we have to do is to connect these two together. So we'll have a graph that looks a little bit funky, but essentially it looks like this, right? So we have a graph that essentially looks like this. And remember how we determined that there's 3 solutions? So it looks like a cubic function. So you see how our function actually looks like a cubic function. So that's like another way to check whether we have the sketch correct or not. And that's how you do the sketching of polynomials. All right, I'm gonna launch the poll one more time. And you're gonna tell me where you are, right? So I'm gonna, before you do the poll, I'm gonna label them, okay? So if you still don't understand how we got the -5 and -2, you're gonna put A in the poll. If you don't know how we got the multiplicity of 2, that's gonna be B in the poll. If you don't know how we got the positive or negative, that's gonna be the C in the poll. And then if you don't know how the graph was drawn, you're going to put D in the poll. And if you understand everything, you're just going to put the E. All right. So A is if you don't know how we got -5 and -2. B is you don't know how we got the multiplicity. C is you don't know how we got the positive or the negative. D is you don't know how we got the graph. E is if you understood it. All right, take a few more seconds. Awesome. It seems like we are getting it, which is great. But if you have any other questions, feel free to private message me, all right? So that's the notes that we have for today. Awesome, awesome. All right, we're gonna look at our assignment, okay? This is our assignment, assignment 36. So as always, make sure you upload your notes. You have your notes here. And then for part 1, depending on your track, if you're on track, you're going to choose 8. If you're in honors, you're going to choose 10. And no stars, you have another. I need a raise. Where do I need a raise? Oh, I'm good at explaining. Thank you. Thank you for the compliment. Awesome. Yeah. All right. So I was at, if you're at star, you have another assignment, right? You have access to that assignment. So you can either do on paper or you can do on computer. So it's a Desmos activity. You get to choose which one you want. It's still the same like number of questions. You have 8 slides on Desmos for on track, and you have 10 slides for honors. Okay. So here are the options that you can choose from. Do we have a question that we want to work on together so we can get some questions started for assignment? Because we still have about 10 more minutes. So hopefully we can get some questions done and you guys can all turn in the assignment, okay? Is there any question that we want to work on together? Yes, no, maybe. No? You guys are all good? Don't want to work on any additional question? Okay. Well, just make sure that you submit your assignment, okay? But if you still don't understand the content, I have office hours tomorrow, so feel free to drop by. Yeah. In that case, if you've taken, I have office hours from 10:30 in the a.m. till noon. Or if you don't have availability during that time, you can also, let's see, what's best. You can also send me an email and we can work on a time together. Chelsea, do you think you're gonna come to office hours tomorrow? Oh, actually, no. You guys have class from 10:30 to 12 on Wednesdays now, right? Yeah. So just send me like an email if you want to meet tomorrow, or I'll have the office hour same time, 10:30 to 12 on Thursdays, Tuesdays and Thursdays, and by appointment anytime. I also have office hours on Friday. So if you want to work on any previous assignment, we can do that. Yeah, just email me, okay? Yeah, just make sure you turn in the assignment. I'll be grading them tomorrow, and I'll leave you comments on things that you're unsure about. Yeah, feel free to come by my office hours. I love talking to you guys and helping you guys out. Yeah, bye. Francis, do you have a question that you want to work on together, or you're good?
No, I'm good.
You're good? Okay.
Yeah.
All right, just make sure you turn in an assignment, all right? You've been really good with turning in, so I'm not worried.
All right.
Yeah. All
Bye,
right.
miss.
Bye.